Today we're going to look at lesson 4, which is on scaled relationships. The first activity, which is kind of the warm-up activity, is looking at these polygons that are scaled copies of one another. So we're told right away in the description, these are scaled copies, so we can trust that information. They do look the same, so that's good, but we don't really need to check any measurements since we're told that they're scaled copies. Now, the first question asks to find two pairs of corresponding angles. And remember, we've been talking a lot about corresponding as being the same location on a figure, just on a different figure. So if I were to look at the angle here on this first figure as DAB, that would correspond with two other angles that are on the two different figures, and that would be HEF and LIJ. And we would write those with an angle symbol. Angle DAB would correspond with angle HEF. The next question asks to name two pairs of corresponding sides, and we could really pick any of those. But if we were to say side AB, that would correspond with side IJ or EF, either one of those. Next, we're going to look at the second activity here called three quadrilaterals. Again, this is the part 2 of that. So these three figures are the same scaled copies that we were just working with. But now what we're going to do is we're going to take a look at some measurements. Now, yesterday we talked a little bit about this, but when we have a diagonal side on a figure, it's really hard to measure the length of that side without having a measurement tool like a ruler. Because we have the grids behind it, those are a great way of finding measurements. They just don't align with diagonal sides in this way. So trying to say the length of this side in these grid units behind it would be impossible. So what we're going to do instead is we're going to look for distances, corresponding distances that we can compare. Yesterday we were drawing a shape around a figure and comparing those, and that's certainly something that we could talk about as well. Instead, what we're going to look for is we're going to look for distances between points of this figure. So if you look at the table in question 1, it's first talking about quadrilateral ABCD, and it wants to know the distance that corresponds to DB. So we're talking about the distance horizontally through the figure that would connect point D to point B. Now, if we go to the figure beside it, which is figure EFGH, we would be talking about this corresponding distance from H to F. And in the other figure, we would be talking about L to J. Okay, then it's going to change directions. And so to find these distances, we would just count the square units that line follows to give a measurement. If we're looking the other direction, we're looking vertically, it wants to know distances that correspond to AC. So AC would go vertically through the shape. We'd be comparing that to EG and IK in the other two figures. Now we're going to go ahead and fill in that table. So in the next figure, the distance between H and F would be 6. The distance between L and J would be 2. That was the horizontal distance going through the center of each of those figures. Now we're going to talk about the vertical distance going through each figure. So AC in the first figure is 6 units. From E to G in the next figure, that's 9 units. And from I to K, that is 3 units. Now, the second question says to look at the values in the table and comment on what you notice. one thing to point out here is that even though these distances are not sides of the figures, what we can actually see is that they're still following the same scale factor. So what I mean by that is if we were to look at these first two figures here. Now remember, we're comparing these two horizontal measurements and these two vertical measurements of the figure. So if I were to look at creating ratios for the horizontal distances, if I went from figure A, ABCD to figure EFGH, I would make a ratio with those two distances of 4 to 6. All right, and you can see those right here. If I made a ratio of those two figures and their vertical distances, seen here, I would write 6 to 9. And what you can see is that each of those ratios will simplify down to the same scale factor. 4 to 6 could be simplified if we divided both by 2 as 2 to 3. If I did the same here with 6 to 9 and divided each number by 3, I would also get the same simplified ratio, being 2 to 3. Okay, so that tells me that figure A is 2/3 the size. I said figure A, sorry. Figure ABCD is 2/3 the size of figure EFGH. All right, those match, and those would be scaled copies of one another. And we were told that already, that they are scaled copies. For the third question, it's talking about a different figure here. We're looking at these large W-shaped figures. It tells us again that they are scaled copies. The larger figure is a scaled copy of the smaller figure, so that means this figure here is the original. And this figure here is the scaled copy. Okay? Now, because it's an irregular shape, we're dealing with measurements that are going to be difficult to calculate. Now, luckily, we do have a measurement on two corresponding sides of this figure. So the original is 6 units long, and on the scaled copy, it's 15. Now, the question, part A, says, if the distance from A to E is 4, how long is the corresponding distance in the second figure? So let's take a look here. If we have a distance from A to E being 4, the corresponding distance would be from H to L, and it's unknown. That's what we need to find. So what we need to know is, what is the scale factor? The scale factor is going to be found by taking a measurement on the scaled copy and comparing it to a corresponding measurement on the original. Now notice that our scaled copy is getting larger. So right there, that should tell you our scale factor must be greater than 1 in order for that to happen, because we're going to multiply by the scale factor for all other measurements. So let's look at our two corresponding sides. So on the scaled copy, we had a side of 15 units, and its corresponding side on the original was 6. All right, now it would be good to simplify that. 15 and 6 can both be divided by 3. So 15 divided by 3 is 5. 6 divided by 3 is 2. So 5/2 is our simplified scale factor. Now, it's okay to have an improper fraction, and we'll get used to using those a lot more. But certainly, if you feel more comfortable changing 5/2 to 2.5, that would be fine also. All right, so using this 5/2 as our scale factor, what we need to do is we need to figure out what the distance, the corresponding distance of A to E is here on the scaled copy. So we're going to take this distance of 4, we're going to multiply it by our scale factor, and that will tell us the distance on the scaled copy. That means we're going to take 4 times our scale factor of 5/2, and that's going to equal 10. So the distance from H to L is 10. Then it asks us again, if IK equals 5, IK is the distance on our scaled copy. If IK is 5, what is the corresponding distance on the original figure? So that's going to be the distance from B to D. All right, what we're going to have to do is we're going to have to work backwards. So instead of taking a measurement like we just did on the original and multiplying by the scale factor, we're going to work in reverse by taking the distance on the scale factor and changing it back to the distance on the original. Now there's 2 ways to do that. One way that you might be thinking is to do the opposite of multiplication like we did here, we could divide, and you'd be right. We could take our distance of 5 and divide it by our scale factor of 5/2. That's a possibility. The only thing is when we're talking about scaled copies, we want to always be thinking multiplication. There is a way, and we did some of this with our warm-ups and different things the last couple days, there is a way to multiply by a number and undo what multiplying by 5/2 is. What that is using the reciprocal. If I were to take 5 times the reciprocal of 5/2, which is 2/5, I will calculate in reverse what that scale factor did. So notice reciprocal. I took my numerator and denominator and reversed them and flipped their places to get 2/5. This multiplying by a reciprocal undoes what multiplying by 5/2 does. So my answer to that is 2. That tells me the distance from B to D is 2 for that question. Next, for the third question, we're going to look at 2 quadrilaterals there. And the first question tells us that this smaller polygon is a scaled copy of the larger polygon. But no, that's what Mia said, but Noah disagrees. So let's look at that. We don't really have any measurements to base our decision on just yet, but looking at those figures, they do look similar. They don't look too distorted or stretched or squashed. What we need to decide is who we agree with. Is it Mia or Noah? Who is correct with that comment? Are these 2 figures scaled copies? Well, since they look similar, really what we need to do is get some measurements. And it's going to be very tough to get some measurements of these sides because, again, they're diagonal lines and we have perpendicular grids that don't really line up with them. So we're probably going to have to look at some of those other distances hidden inside the figures to calculate this. Let's look at the next question. We're going to fill in this table. So it wants us recording, if I go back here, it wants us recording the distances horizontally through the figure and the vertical distances through the figure. So let's fill that in. Horizontally, we have a distance of 6 for distance between point X and point Y. For Z and C, it's 4. For the vertical distances, we have 9 and 6. All right, now what you would want to be noticing is that the ratio comparing these 2 distances, so the horizontal on one figure to another, and the vertical distance on one figure to another do fit into the same ratio. These can both simplify to 2 to 3. So it looks like we have a scale factor that was used in these figures. All right. Now, in the third question, it wants us to measure at least 3 pairs of corresponding angles using a protractor. Now that's going to be a little tricky for some of you. What we're going to do is go back to this figure here and let's really closely look at a couple of these angles. The first one I want to look at is this top angle, angle X and Y. Okay, and looking at the measurement of this angle, when we take the measurement of an angle, we're talking about the distance in degrees between those two rays, and we're going to compare it to the distance between these two corresponding rays on the scaled copy. Now, if you look closely, this looks like a larger angle. It's more spread out than it does here. All right, let's look at another one. If we look at angle NXJ, let me try to trace that again, NXJ, compared to its corresponding angle HZS, it is slight, but this angle HZS looks like a larger angle than it does here on the figure. And if we were able to trace these on a piece of paper and overlay it, you would see that they're not the same. These angles are not the same. This is kind of a trick question because using our distances, it appeared to follow the same scale factor. But if we go back to these images, we can see that the angles are different. Now that kind of makes sense because if I were to trace these two horizontal grids, all right, notice that this way, this angle is only taking up 1 unit, just like it is here. But what's happened is we've stretched this top angle over 6 spaces between X and Y, and it's only been stretched over 4 spaces or 4 units between Z and C. Now that cannot be the same angle because of those changes, so that's distorting the image. Even though these two figures look similar, they are distorted because it hasn't been consistently changed. In scaled copies, and this is really important, guys, so write it down. In scaled copies, all angles must be the same. That'd be a great thing to add to your Know It notebook. All right, lastly, we're going to jump to this final question for today, which is looking at 2 more quadrilaterals here. Kieran says that the second smaller polygon is a scaled copy of the larger, but Lynn disagrees. Do you agree with either of them? So we need to look at this. Now, what I just told you is that the angles have to be the same. So I can see 2 120-degree angles on both of these figures in the same corresponding location. So that sounds good. And it's also the same down here. So it checks that box that the angles are the same. Angles are same. All right, that's going to get a check. Now, we also have to check that the scale factor used is the same. All right, and we're going to have to do that by comparing some corresponding side lengths that we know. So let's look here across the top. From point D to C, from side D to C and H to G, we have going from a measurement of 2 scaled down to a measurement of 1. So that would give us a ratio of 1 to 2, or a scale factor of 1/2. Let's compare that to 2 other corresponding sides. So we have A to B being 6 units, E to F being 4 units. If I write that ratio 4 to 6, is that going to simplify down to 1/2? It's not. It's going to simplify down to 2/3, meaning the scale factor used here was 2/3, and the scale factor used above was 1/2. Do they have the same scale factor? Absolutely not. So they are not scaled copies, and that means Lynn was correct to disagree with Kieran. Okay, please take a look at the rest of the questions in the packet for today's lesson, and don't forget about your practice problems and the help that I'm offering on Zoom throughout the day. Talk to you later.